So in this example, we're trying to integrate this fraction here, and it's a polynomial fraction because we've got a polynomial on the top and the polynomial on the bottom. And this is different to the previous example because this is actually an improper polynomial fraction. The reason why is the highest power on the top is 2, and the highest power on the bottom is also 2. So we've got a degree or order 2 polynomial on the top and a degree of 2 polynomial on the bottom. So whenever the highest power on the top is the same as or greater than the highest power on the bottom, that means we've got an improper fraction. And that means that before we do partial fractions, we're going to have to do polynomial division. So you can choose your favourite method for polynomial division. Feel free to skip on if you are confident and you already know how to divide polynomials. So the first method that I'll look at is long division. So with long division, we're going to put 9x squared minus 4 on the outside, and we're going to put 9x squared minus 3x plus 2 on the inside. And we have to ask ourselves, what do we times 9x squared by to get 9x squared? Well, that's just 1. And then we need to times everything on the outside by 1. So we're going to do 1 times 9x squared, which is 9x squared, and 1 times minus 4, which is minus 4. And I'm going to line the minus 4 up in the constants column, just so I don't make any mistakes when I do the subtraction. And actually, you could put 0x there if you prefer. And then we need to do the top line take away the bottom line. So 9x squared take away 9x squared is 0x squared. Minus 3x take away 0x is minus 3x. And 2 take away minus 4 is plus 6. And this is the remainder. So if you remember, that means that we can write our fraction 9x squared minus 3x plus 2 divided by 9x squared minus 4. We can write that fraction as our quotient, which is this number here, which is just 1. And in general, it won't be 1. It could be a multiple of x. It could be even be a quadratic in some cases. But in this case, it's just 1. And then plus our remainder, which was, we've already found that, minus 3x plus 6. Divided by, so on the top's the remainder, and on the bottom is the denominator, which we're dividing by, which is 9x squared minus 4. So our quotient went there, and our remainder went on the top of that fraction there. So if you wanted to do grid method, then it's fairly simple with grid method. We're basically asking ourselves, if we wanted to write 9x squared minus 3x plus 2 is equal to some multiple of 9x squared minus 4 times by something, we're basically asking ourselves, what is that something? So if you wanted to lay it out on a grid, it's fairly simple that that something is going to be 1 because we need to get 9x squared. So 9x squared times 1 is going to give us 9x squared. But if you wanted to lay it out on a grid and you didn't spot that, I guess you could put 9x squared and minus 4 along the side. And then we're asking ourselves, what do I need to put along the top here so that when I times them together, we get 9x squared minus 3x plus 2. Well, we need 9x squared, so we need to put a 1 there. So we're going to do 1 times 9x squared, which is 9x squared, 1 times minus 4, which is minus 4. So that means that we can put 1 here. And we need to add on some remainder. And it's quite clear here that the remainder, well, let's work through it. If we multiply these two together, we're going to have just 9x squared minus 4. So we need to work out, what do we need to add to this in order to get minus 3x? Well, we just need to subtract 3x. And at the moment on the right hand side, we've got minus 4 and we want plus 2. So we're going to have to add on 6. So again, that means that we can write this fraction as 1 minus 6 or plus minus 6x plus 6 over 9x squared minus 4. So once we've done division, we've now got a proper fraction where the order or the highest power on the numerator is 1 and the highest power on the denominator is 2. So we can now do partial fractions on this fraction here. So we're kind of treating this like a separate part of the question now, and we're just going to do partial fractions on this fraction here. And in order to do partial fractions, we need to factorise the denominator. So we're going to have 3x, this is a difference of two squareds, so we know that we can factorise it as 3x plus 2 and 3x minus 2. And if we do partial fractions, we know that we can write that as a over 3x plus 2 plus b over 3x minus 2. So now if we times 2 by the denominator, we're going to have 3x plus minus 3x plus 6 is equal to a times by 3x minus 2 plus b times by 3x plus 2. And then you can use whichever method you prefer. I'm going to use substitution again. So I want to make this bracket 0. So in order to do that, I'm going to sub in x equals 2 over 3. And on the left hand side, if I sub in 2/3, I'm going to have 4. And on the right hand side, I'm going to have 4b. So that tells me that b is equal to 1. And then next I'm going to try and sub in a value of x that makes this bracket equal to 0, and that would be minus 2/3. So if I sub in minus 2/3 into the left hand side, we're going to have 8, and if I sub it into the right hand side, we're going to have minus 4a. So that means that a is equal to minus 2. So that means that we can write this fraction as minus 2 over 3x plus 2 and plus 1 over 3x minus 2. So we can now sub this into our previous expression. So what we're trying to integrate is 1 minus 2, I'm going to write this as plus, minus 2 over 3x plus 2 and plus 1 over 3x minus 2. You can either put the minus on top of the fraction or you could have put the minus out the front, it doesn't matter. So we're trying to integrate this now. So we've just got to integrate these three terms separately. So the integral of 1 is just x. And then let's try and integrate this term here. So I've written it as plus, and then I've put minus 2 on the top. So let's leave it as that. And so we're going to do plus, and then we need to work out what's the integral of minus 2 over 3x plus 2. So you can use whichever method you prefer. The formal method would be to use a substitution. So we'd let u equal 3x plus 2, and that means that du by dx is equal to 3. And if we rearrange that, we'd get dx is equal to 1/3 du. So our integral would be the integral of minus 2 over u times by 1/3 du. So if we work this out, we'd have minus 2 times by 1/3, which is minus 2/3, and then the integral of 1 over u, which is natural log of u. But we know that in this case, we said that u is 3x plus 2. So we can write this as minus 2/3 log of 3x plus 2. And then finally, we just need to integrate this final term here. So it's the integral of 1 over 3x minus 2. So if we do a formal substitution, we're going to say u is 3x minus 2. So du by dx is equal to 3, which tells us if we rearrange this, we're going to get dx is 1/3 du. So when we integrate, we're going to have the integral of 1 over u times by 1/3 du, and that's going to be 1/3 times by the integral of 1 over u. The integral of 1 over u is log u, so this is going to be 1/3 natural log of u. and then we can replace u with 3x minus 2. So this is going to be plus a third natural log of 3x minus 2 plus c.